This is Mr. Maxwell for Pingree AP Biology. I want to talk about, in this screencast, about how to deal with a question like this one. Take a look and read it. So basically, if you look at this data, if you do this cross, you would expect in the F2s, you would expect even numbers in each of these categories. In other words, you would expect a 1 to 1 to 1 to 1 ratio. And of course, you can do a chi-square on this, and if you do the chi-square on this, your expected values are here, and you get a chi-square of 1,765, which is way off the charts. This you're going to reject your null hypothesis that this is a 1 to 1 to 1 to 1 ratio pretty soundly. And so something else is obviously going on. And if you look, the red vestigial and the purple normal are not like either of the parents. In other words, we have red eyes, which is a wild type trait, and vestigial wings, which is a mutant trait. And so we've mixed those traits. And so here's what's going on. We have a female who's wild type. The plus here means that she's wild type for the eye color, and she's also wild type for normal wings. And so she has 2 chromosomes like that. And then the male is double mutant, so he has purple eyes and he has vestigial wings. And so when you cross these, you're going to get F1s that have 1 copy of the wild type genes on 1 chromosome from mom, and you're going to have a copy of the recessive alleles from dad. Okay, and it doesn't matter if they're male or female, they're all going to be like that. So then if you do a test cross where you take one of the F1s and mate to a recessive background, what you're going to expect is if they were not linked, and these are actually on the same chromosome, so they are linked, you would expect a 1 to 1 to 1 ratio, but in fact you actually don't get that 1 to 1 to 1 ratio. Because the only way to get a 1 to 1, the only way to get those recombinants is to have a crossing over event happen. And what we see here, this is a transmission electron micrograph of some chromosomes in meiosis 1, and you can see that the chromosomes are kind of interlaced here. And what will happen is pieces of one of the chromosomes will get attached to another chromosome, so you get a chromosome that's a recombination of the two. And so here we have your wild type, in which there was no crossing over event between those 2 gene loci. Here's another parental type where there was also no crossing over. But in these guys, the recombinants, you had to have a piece of one chromosome get swapped for a piece of another chromosome to get this recombined chromosome. And so, the closer together these gene loci are, the fewer recombinants you should get, because it'll be harder and harder to get a crossover event between those 2 gene loci. And so what can we do with this data? Well, further, we can say that the total number of recombinants divided by the total number of recombinants divided by the total number of flies gives us a recombination frequency. And if we multiply by 10, we can turn that number into map units or centimorgans. And so the bigger this number gets, in other words, the more recombinants we get, the further apart those things are, and the fewer recombinants we get, the closer together 2 gene loci are. And that's basically how you do that.